dear students. Today we are going to start chapter number 13, Direct and Inverse Proportion. In previous classes, in the beginning we learned about ratio and proportion. Okay, so what is ratio? Ratio is the comparison of two similar quantities or two quantities by the method of division. We learned already about ratio. And if two quantities x and y are in ratio, we write it like this, which is equal to any numbers or anything. X is to y. We call it, you read it as x is to y. And in a ratio, the first term is called antecedent and the second term is called consequence. This we have already learned. Now, if one ratio is equal to another ratio, if I say x is to y is equal to a is to b, then we say that x, y, a, b, both of them are in proportion. That means whatever change will happen to y when x changes, maybe when x increases, y may decrease, or x increases, y may also increase. Both of them may change in the same direction or in the inverse direction. Same way a and b also will change. That means if x increases, y also increase. Then if a increases, b also will increase. Otherwise, when x increases, if y decrease, then if a increase, then b also will decrease. Did you understand? So, if in one side, if this part is going up and the other part is going down, then similar way on the other side also will vary. So, such type of ratios, two ratios which are equal are called in proportion. Now, if you take an example, if A is to B is equal to C is to D, then we say that A, B, C, D, these three numbers or these three terms are in proportion. And if they are in proportion, we write either like this, or also we write, instead of equal to sign, we can write two times ratio symbol. Okay, so 4 dots. Then we call A is to B proportionate to C is to D. Okay, now here the first and the last terms are called the extremes and the middle terms B and C are called the means. Now, how will you check whether the given numbers are in proportion or not? Now, in whatever proportion they are, in whatever way they are related, then if these two ratios are equal, the product of extremes will be always equal to the product of means if they are in proportion. So, to check what we do, we check this way. Product of extreme, that is A into D. Is it equal to B into C, that is product of means? If they are equal, then the given terms are in proportion. And if they are not equal, they are not in proportion. Now, I told you there are two types of proportions. That is, when one increases, the other term also will increase. And if one decreases, the other term also may decrease. Such type of proportions are called direct proportion. Directly they are connected. Means in one side increase, then the other side also will increase. And if the first quantity decrease, the other quantity also will decrease. For example, let us take, if you take a vehicle and its speed is marked as x and its distance covered is marked as y. When the speed increase, the distance covered also will increase. Okay, so these two quantities are in direct proportion. But when the speed increase, the time taken will decrease. Okay, so that is inverse proportion. So direct proportion and inverse proportion. First we will learn about direct proportion. For example, if x and y are in proportion, usually we write x proportionate to y using this symbol. Okay, one sleeping 8, little open 8. That is called, this symbol is for proportion. So x proportionate to y, then when x increases, y also increase if they are in direct proportion. And when x decreases, y also decrease. That means if x is proportionate to y, x upon y will be always a constant. The ratio of x and y will be always a constant. Let us see. I gave you an example. If x is the speed and y is the distance. I just took this example. If the speed is 2 km per hour, the distance covered is 10. If it is 4, then it is 20. If it is 6, it is 30. 8, it is 40. This way it is given. So let us check x upon y. 2 upon 10. What is 2 upon 10? 1 2s are 2, 5 2s are 10. Now let us see 4 upon 20. 4 1s are 4, 5 4s are 20. Then here 6 and 30. 6 1s are 6, 6 5s are 30. 8 and 40. 8 upon 40. 8 1s are 8, 8 5s are 40. So in all cases, when you divided x upon y, we got the answer 1 upon 5, 1 upon 5, 1 upon 5, 1 upon 5. That is a constant term. Okay. So if you get like this, then the proportion is direct proportion. Now we already learned that if x is proportionate to y or x is directly proportionate to y, then x upon y is equal to k. What does it mean? If you give different values to x and y, for example, just now we saw one example, 2, 4, 6, 8 we gave, and for y we gave 10, 20, 30, 40 like that. So we got the value of k as 1 upon 5. Similarly, if you give any values to x and y in such a way that x upon y is equal to k, then we get a relation, that is x1 upon y1. That means the first value of x upon the first value of y will be equal to the second value of x upon second value of y, which will be equal to the third value of x upon third value of y. You can write any number of terms like this. In all the cases, in all the cases when you find this ratio, you will always get the same constant. Okay, means in a particular case you will get a constant term. Okay, it doesn't mean that in all the type of sums you will get same number. The number may change, but in a particular situation the number will be a constant. This constant is called the constant of variation. So the constant of variation will tell you how many times it is increased or how many times it is decreased. Okay. That is, if you take in general two terms, to check whether the given ratios are in direct proportion, if you cross multiply x1 y2 is equal to x2 y1. If you get this way, then the given proportion will be direct proportion. Okay. For example, if you take the price of sugar and the amount of sugar. Okay. Now for example, you buy 5 kg sugar for 100 rupees. Now if you increase the price of, the weight of sugar, instead of 5, if you buy 6 kg, then will this amount increase? Of course, yes, it will become 120. Now if I increase to 7, then this will become 140. Okay. Similarly, if you increase the weight of sugar here, or the amount of sugar that you buy, the weight of sugar you buy, then the amount of money that you have to give automatically will increase. Now, in what way it increase, you see? Let us divide and check in all cases whether you are getting same number or not. 5 ones are and 5 20s are. 6 ones are, 6 20s are. 7 ones are, 7 20s are. So here the constant is 1 upon 20. That is, for every kg, how many rupees will increase? 20 rupees will increase. Okay. So this is the constant of variation in this particular condition. In the first question, first example we saw, it was 1 upon 5. So according to the situation it will change, but in a particular sum the constant of variation will be a constant. Okay. That's all for today. In the next class we will do few more examples of direct variation. Thank you.